3D printing is really a very interesting technology because it's existed for a couple of decades. It was actually first developed back in the 80s or so. But in most recent years, there was a huge big hype about 5 years ago about 3D printing, everybody having one in their home, and now it's kind of come back down and it's fallen into kind of the specialty tool area of CNC machines and that kind of thing. If you have a lot of money, you can buy a really nice 3D printer that's on a large, highly expensive scale, $100,000 or more, with high accuracy and can output things very well. And then you've got the sort of consumer ones, the hobby ones that someone who's familiar with technology can put together and use. But there's not really a consumer level one where you go to your phone, go bloop, and the idea comes out at the end. And now there's some really good reasons for this. Everybody who was touting the idea of you go home and you print out a toy for your kids and everything else, that's okay, but the effort and the return on it has never made it worth it. Because a 3D printer takes 8 hours to make a G.I. Joe toy soldier toy about this big, or 3 hours, whatever, and it's not held together very well. It's kind of nice, the accuracy isn't that great for the consumer versions, so on and so forth, and you gotta sort through it. It's easier to just go on Amazon or something and buy 10 or 100 of those soldiers and have it show up 2 days later. 3D printing hasn't outdone shipping. Those have progressed farther than that. But here's the thing with 3D printing. It does allow prototyping very quickly, and which is why it's fallen into that space where people who need a prototype within a couple of days and for very cheaply want to use one. We use our printers every day. They're running almost 24/7 creating parts for prototypes or actually for manufacture. This is the thing that's special about 3D printing. They're a completely new method of manufacturing, and they allow new capabilities. And we have to learn how to use those capabilities as opposed to using the device. Let me give you an example of this. When electric motors were first created, factories who normally had a large steam plant, a big belly of the beast down in the center of the plant that had wheels and gears and shafts coming out from this giant turbine running all of the machines in the plant. And all of those machines would stick a pulley into the shaft to run a drill press or a grinder or anything else. When electric motors came out, they did the same thing. They just pulled out the big steam engine and put in a big electric motor. And because of that, new improvements didn't really happen. It was like, well, who cares? You had an electric motor. That doesn't do anything for you. It wasn't until people figured out how to put an electric motor into a drill press, a small electric motor into the drill press, into the grinder, everything else, that they finally figured out, oh, this is really handy because it creates portability, it is more functional, and you're able to change the layout of the plant so that you can create an assembly line as opposed to a big old beast in the base that powers everything out like a spider web. This is what 3D printing does. You have to use the capabilities that the unique new technology gives you. And Slant, we kind of stumbled into this when we started working with the little arm. These are the benefits that 3D printing has. It allows you to control the small scale structural capabilities of a material. This is how this works. Normally, say you have a piece of aluminum. There's only 2 ways you can use that piece of metal. You can use a bunch of them, put it into the shape of a truss somehow to create strength and lightness in it, or you can change the atomic capabilities of that piece of aluminum by throwing in a little bit of steel or a little bit of copper or something else to make it lighter or stronger or more flexible. But you can't really change the in-between space, the space between big and microscopic, tiny, tiny atomic. But 3D printing does allow this because 3D printing now allows us to create a truss a half a centimeter wide going throughout this material, make it hollow with internal patterns and lattices that make it stronger. If you look at our little arm right now, what we have is what we needed was a material that was light enough that the small microservos were able to work with it, but still strong enough that the arm could be functional. You can't do this with molds or anything else. So 3D printing was really the only option that we could use for this because it creates an incredibly light but strong plastic component that can't be created with any other process. It's impossible. 3D printing also does allow the creation of impossible shapes. shapes that you can't create with a blow mold or even a CNC machine because you have to make a weird turn or some kind of tunnel in there that's cut out or something else along those lines. You get the idea. Put in a hole where it can't possibly be put with normal technologies. 3D printing, since you're building it up layer by layer, it can be any shape you can possibly imagine. There's no limitation on that. That also was really important in the design of the little arm that we made because we had to use shapes and designs that let this snap together easily and be semi-modular that you can't create with any other kind of manufacturing process. So people might ask us, why don't you create those in thousands at a time or something like that with the mold? And we simply tell them, we can't, it's impossible. There's parts of this arm that cannot be manufactured with any other method than 3D printing. And that's what's special about it. 3D printing allows you to control the small mechanical capabilities of a device at a level that's never been possible before. It also allows you to create impossible shapes. This is why it's normally used for prototyping. Though prototyping is kind of a traditionalist idea. It's not really a new thing. It's a new tool you added in. But we haven't really come to the point where we've used 3D printers in a completely new and imaginary way. When people design something, a product, they design it to do what it did before. Like if they're making a new hair clip, well, they design it like every other hair clip that's ever been made, and then they just happen to have the 3D printer make it. That's not what you're supposed to do. You're supposed to use what it gives you to create something completely new and different. You don't design personal computers like mainframes. You don't design new plastic components that would normally be injection molded to be 3D printed. It's just no point to it. You have to understand what your tools are and use them as they are meant to be. In 3D printers, what's going to make them really take off and become a massive industry as opposed to kind of a big industry, but mainly just because it's a fad, they're degrading back into mainly prototyping. But the way 3D printers will become big is if people design different products that can only be manufactured by the process. Personally, 3D printers are never going to be a very good consumer device because simply the cost of digging the metal out of the ground to make the motors is more expensive than what it takes to create a smartphone. So they aren't going to really get exponentially cheaper, they'll just get smaller and appear to be cheaper. And that's okay, so fine. It costs $500, that's not that big of a deal, but people won't ever use them because the user interface will never be very great either. Again, like I said, when you compare shipping to 3D printing, there's no contest there because shipping gives you a quality product in bulk very quickly, whereas 3D printing might give you one G.I. Joe after a day or two. And I don't care what process you're using, whether it's lithography or anything else. 3D printers simply don't have the output to make it a consumer level device. They don't give us a dopamine boost quickly the way we get when we go on Facebook or anything else. So 3D printers will only come about if they are used as a manufacturing tool for products that cannot be made any other way. Products that either are too complicated to be manufactured in any other way or simply need to have mechanical capabilities that are tweaked at a small level but not an atomic level. And that's where they really come into their own. And we were lucky to do this with the little arm. We found a component that was special about it. The little arm has impossibly shaped pieces that can only be made with 3D printing, but because of that, they're light enough that very small and affordable motors can move those pieces around. That's what we figured out at Slant. But if you're really looking to use 3D printers and somehow get into the industry, don't work with 3D printers. You don't want to do that. That's like trying to dig up gold when you can sell somebody shovels. Figure out how to make a product that can only be 3D printed. That's what's special. Right now it's mainly art. Only artists do that right now. If you can find something functional that people can use that's 3D printed, then you're onto something really cool.